My name is Andrea. I'm originally Italian. I work as an independent cloud-native consultant for a company based in the Netherlands. That's where I'm based. I live in Amsterdam. And this company is called Overstory. What we do at Overstory is using and leveraging the power of cloud-native solution to prevent wildfires. While there are a lot of solutions for containing a wildfire that already spreads out, preventing wildfire is something that is not as easy. It's not easy to do, it's not well understood yet, and this is what we try to do at Overstory. Wildfire is a problem you might not be too familiar with, let's put it this way. It's definitely not a massive problem here in Denmark. In Europe, in the southern region like Italy, Greece, Portugal, or Spain, wildfire during the summer months can cause massive destruction. And of course, this has been also a problem in the US particularly, where the area is really vast and it's difficult to manage wildfire in an efficient way. Just earlier this year, in January, there was a massive wildfire in the Los Angeles area that brought a lot of destruction and a lot of deaths, unfortunately, around the area of Los Angeles. This destroyed so many acres of land, families, communities, houses, companies, and little and small businesses as well. Wildfire bring with them a big amount of destruction, something that is really difficult to imagine. Just to give you a few numbers here, the Southern California wildfire, the one we had in January, earlier this year, brought 29 deaths, over 200,000 people got evacuated, around 18,000 homes got destroyed, and 57,000 acres of land burned down. These are massive numbers. They're not easy to imagine, they're not easy to comprehend. But just to give you an idea what 57,000 acres of land burned means, this is the equivalent area on top of Copenhagen. I've tried to do the same with Aarhus, but it was just way too vast. This is the equivalent area of 27,000 acres of land. So that's a massive amount of land that brings a lot of destruction to so many families and people that are part of our communities. One thing I didn't know before starting to work with Overstory is that in the US, in California specifically, over 60% of the most destructive wildfire are caused by power line failures. So, for example, like the power grid infrastructure fails, a cable that brings like high voltage electricity falls on the ground, and there you go, a massive wildfire is ignited. And another thing I didn't know is that this wildfire is not even the biggest one that California experienced. Back in 2018, the Camp wildfire was also almost 3 times as big. And this brings all kinds of challenges when managing wildfire. Keep in mind that here we're talking about wildfire prevention, not reaction. We're trying to catch a wildfire before it spreads out, not once the wildfire has spread out already. And Overstory focuses exactly on this problem, wildfire prevention for wildfires that are caused by power grid failures. So, a cable falls on the ground, something like this. How do we do that? We do that by combining different information. Wildfire prevention is not an easy task for a couple of reasons. The first one, power lines are a complex system. You have to think that you have power substation, mains, power plants, all the way to your power plug that you use to charge your own laptop. There are an extremely complex network of cables, high voltage line, low voltage line, and so on. And also they bring electricity to our communities 365 days per year, uninterrupted. Our hospitals rely on it, our families, our companies, and so on. The second reason why preventing wildfire is very complicated is that failures are very often sudden and catastrophic. Another example from this year, in April this year, a power substation failed at the Heathrow Airport of London. This is one of the biggest airports in Europe. This led to the airport being closed for over 24 hours, and over 300,000 passengers got affected, and thousands of flights got disrupted. And again, this was a small power substation. Finally, most of the infrastructure is also subject to atmospheric agent. In Europe, it's very common to have our power lines underground, but in the US, it's much more common to have the lines overground. This means that they're subject to all kinds of atmospheric agent, rain, wind, hail, heat, cold, all year around. Moreover, inspecting those power lines is not easy. Until now, the way it has been done is just like sending someone to check visually those power lines. And that's also complicated because sometimes those power lines, they cross private properties. So you need to get authorization, you need to schedule an appointment, and it's also very, very expensive. So at Overstory, we take a different approach. So instead of looking the power lines from the ground, we look at them from the sky. So we use satellite images and aerial images to monitor the power grid from the satellite. Basically, we combine this information together with the information that we get from the electricity provider, and we try to build a profile for the electricity provider of their network that highlights areas that are a higher risk of wildfires. We do that in 3 different steps. The first one, we collect images. This is a mix of satellite images and aerial images. The highest resolution that we use is 15 centimeters. This helps us to get a good profile of the land. So we know which trees are there, which species, the height, their health, and so on. Different trees grow at different speeds. So it's very important to get this kind of information from our satellite images. Then we combine this information with information that we get from the utility provider. Think, the energy company in Denmark that brings electricity to your homes. Basically, they give us a detailed map of their network, so we know exactly where are the poles, where are the lines, what's the tension of the electricity going through a certain segment of the network, and so on. And finally, we combine these 2 informations together to get a risk profile, pretty much, for the whole network. So the utility provider can access our platform and see segment by segment what's the risk of wildfire in that particular area. The idea is that when the vegetation gets too close to the power lines, when our system detects that there is an elevated risk of wildfire in a certain area, we notify the energy provider so that they can go and trim the vegetation before a wildfire spreads out. How do we do that? Well, I joined Overstory some time ago. We've been working together for quite some time. And in the beginning, when I joined them for the first time at the end of 2020, we were a company of 12 people. So little company, a lot of potentials, still trying to find product market fit, still trying to build a solution that would work for energy provider. So as the motto says for startup, move fast, break things. We started very simple. We started just by using a mix of Kubernetes and JupyterLab. Kubernetes was giving us the right flexibility. Some of our jobs take 4 CPUs and 8 gigs of memory. Other jobs can take 72 CPUs and half a terabyte of memory. So with Kubernetes, we had the right flexibility to spin up and spin down the machines only when we needed them to run certain jobs or certain computation. And then we used JupyterLab. I'm sure most of you are familiar with what a Jupyter Notebook is. Basically, it's a tool that allows you to run experiments in data very fast. It's an interactive notebook where you can write your Python code and execute it step by step. And in the beginning, this was fantastic. Our data scientists and data engineers were able to just select the machine that they wanted, select the container image that they wanted, and they would just be ready to go. They would basically just spin up their own environment in the cloud with all the resources that they needed to run a certain computation, and that would be pretty much it. They would just run the computation on their own, pretty much on their browsers. But well, as you can probably imagine, this is not the end of the story. As the number of customers grew, the number of land to scan grew, this became totally unsustainable. Tracking repeatability in particular was a nightmare. So, messages like this were not uncommon on our Slack. Who has this copy of this Jupyter Notebook? Do you remember which Pandas version we used back in 2021 and so on? So, and the whole process was also just very manual. Whenever we needed to get a new scan out, we needed to assign one member of our team to one of our clients and pretty much follow them step by step. This was totally unsustainable. And this is when we decided that we needed to take the next step. We needed to make a next move. If we wanted to grow as a company, get more customers, get more mileage to scan and so on, we needed to automate things. And this is when we made two conscious choices. We wanted to get rid of Jupyter Notebook, at least for automated workflow. By all means, we still use them as of today to explore the data and run quick experiments and so on, but they've proven over and over to be difficult to maintain, difficult to test, and maintaining them in Git is a nightmare. In case you don't know, a Jupyter Notebook is just a giant JSON file. Ask me how I know. And we decided as well that we needed to automate our workflow runs. There was just no other way around it. We needed to make the whole process repeatable over time. And this is when we started looking into a workflow orchestrator, something that could run our processes over and over and over. At the time, there were several workflow orchestrators in the market. We settled on one that was already used by other company in the geospatial world, and this is called Dagster. It's an open source project. We've been working with them, with the company. We've been supporting their open source project for a long time, and it's a tool that I personally really, really like. As I mentioned, it's open source, so you can just use it today. It allows us to develop really, really fast, which is really nice. So you can create your pipelines locally and then run them in the cloud almost seamlessly, which is very nice. Everything is a Python module. And as a cloud engineer first, I can really see how a tool like this is built to run in the cloud, which is what excited me the most. I can give you just a couple of examples. The first one, storage is completely abstracted. I write my pipeline locally, and if the pipeline is running on my laptop, it will just save the files on disk. If it's running in the cloud, it will just save the files on S3 or GCS, doesn't matter. I don't need to code that logic in my pipelines, which is a massive, massive plus. But also, the Dagster team came out with something that then other tools adopted, but I found really genius. Now that we work in the cloud, data has different forms, has different formats as well. In the past, the data was either a database or a file. That was pretty much it. It was either like a Parquet file or a PostgreSQL database, more or less, right? But now that we work in the cloud, data can have a lot of different formats, right? Data can be your BigQuery table. Data can be your Snowflake table, a file on Google Cloud Storage, your import pipeline from DLT. And it has become more and more difficult to understand how data relates with each other. Many of the tools that we have right now, they show how data is built, not how data is connected. And answering the question, how does this BigQuery table relate to this file in Google Cloud Storage, has become really complex to do. So some years ago, Dagster came out with the idea of, instead of working on pipeline, which is something that you can still do in Dagster, but it's not the approach they prefer, you can work with the idea of assets. So instead of focusing on how the data is built, you focus on how data is connected. And this gives you some nice visualization like this, where basically you can really relate data with one another. You can really understand when one data needs to be refreshed because something changed in the upstream, for example. This is a concept that since then has been introduced in also more traditional tools like Airflow in version 3. But I feel like I think the Dagster team was the first one coming out with this idea, and that's something that we really liked. When you deal with satellite images, that it can be like hundreds of gigabytes of data each, having this kind of visualization, not recomputing certain images because you're not sure if they have been processed or not, it's a really important thing for us. As we have been building more and more on Dagster, we started also building our own automation, our own libraries. Since we're a company that deals a lot with trees, we have this transition that we call all our libraries and our clusters with the name of trees. So our internal library is called Maple. And this is a library that basically takes all our knowledge of Dagster and encapsulates it in one library. And so what our developers can do, this is basically a step of a pipeline. They can say, okay, I want this step to run on a machine with 32 CPUs and 390 gigs of memory, which is very effective. And for them, it's just straightforward. It's in the code. And if I want to change that, I just open a PR, change it, and that's it. And they can use this library for all kinds of things. CPU allocation, memory allocation. Do they need a GPU? Some scratch disk space to save some temporary files. An NFS mount. Whatever they need, they can do it from within our library. Where are we today? So we started with Jupyter Notebook and Kubernetes. We evolved into Dagster. But what's the situation at Overstory today? So this is a screenshot I took around 6 months ago. This was the first time that we managed to run a scan end-to-end, no touch. So we repeated a scan that we did for a customer previously, but this time, instead of doing it manually and having somebody check it step by step, we let our platform do it on its own, without any interaction from our developers, from our engineers, which was a massive achievement for us. This was the result of like months and years of work. Back then, this was in March, we were running around 27,000 jobs a week with an efficiency of around 95.9%. Just to give you an idea how much we have grown since March, I took a screenshot a couple of days ago. And today we managed to run around 27,000 jobs in a single day with an efficiency of 98.3%. So the scale we have grown, we got more customers, more delivery. Customers are trusting our product more and more as well, which is, really flattering and really important for us. But this brings its own advantages in terms of scale. What do we have left now? Well, there is still, like the next step. There will still be more customers and more wildfire to predict, pretty much, and to prevent as well. The target, the first target is still the same. We want to deliver these results as hands-off as possible. And while this might seem, simple, when you're dealing with nature, it's really not. Something that I found out as well when I started working with Overstory. If you want to get a satellite image of a certain area, and that day is particularly cloudy, you just need to wait a little bit longer, because the clouds need to go away in order to take the image. So sometimes you have deliveries that you need to give back scans on a very tight deadline, but maybe a certain area has just been cloudy for the past week, and there is nothing you can do about that. The second problem that we're really focusing on tackling in the future is also resource over-provisioning and under-provisioning. Sometimes we have pipeline that can take a very different amount of CPU and memory based on the input image. Sometimes our image can be high resolution, low resolution, bigger size or smaller size, and that influences a lot the amount of resources that we use. In general, what we're trying to do is just prevent wildfires as much as possible. It's a difficult task. It's something that many people are trying to do. And we try to focus more and more on the prevention side rather than on the reaction side. We hope that in the future we will manage to bring these technologies to more and more people, to more and more customers, and get a better chance of our planet in preventing wildfires and making sure our communities are safe over time. Thank you very much for your attention, and enjoy Cloud Native Denmark.